All right, video number 2. Using the roots to solve for the quadratic function. Okay, I know I talked about using vertex form, but we're not going to do that. A lot of times they use vertex form in algebra 2, but we're not going to address that in algebra 1. Okay, the reason being I don't want to throw something new at you in the middle of a project. Okay, so I got to find my roots. What's another name for the roots? X-intercepts and zeros, right? Okay, so I got to go to my graph. I got to find where it crosses. Here I see, oh, -2, 0. Perfect. And here I see negative or positive 1.50, okay? If it's not exactly on there, that's okay. I'm going to zoom out a little bit. So, okay. Right, I'm just doing my best to see where it is at. So we got 1.5 and we got 2. Okay, so I might need to zoom out a little here. Okay, so then I go here and then they're my roots, right? So I know x equals -2 and x equals 1.5. Okay, so this is where I have to work backwards to solve for my quadratic function, right? So roots, x-intercepts, right? We know that everything, if we want it to be set equal to 0. So from here, our first step to work backwards would be to move our 2 over to the other side and the 1.5 over. So if I have x equals -2 and x equals 1.5, I'm going to isolate by doing the opposite, right? So I'm undoing what I did before, -2, add 2, okay? So x plus 2 equals 0, minus 1.5, minus 1.5, they cancel, and x minus 1.5 equals 0. So this is usually the last step going that way, but we're going opposite, so it is the first step here, okay? So before, when we set them equal to 0, then we're going to make them into binomials because we know that their product is equal to the quadratic, right, that we're looking for. And it always equals 0 because it equals our roots, our x-intercepts, where y equals 0, okay? All right, so if I have 2 binomials, how could I make them into a trinomial? I'm not going to factor them. I've already factored. I'm going to do the opposite of factoring, which is to multiply. So next I'm going to multiply. You can use the box method, or you could use FOIL. So I have x plus 2, x minus 1.5 would be x squared. We got 2x, negative 1.5x, and -3, right? So then I'm going to make that into my quadratic, x squared, and then we have a negative 1.5x and a positive 2x, so that would add to be 0.5x minus 3 equals 0, okay? And so that would be my quadratic for my graph here, okay? So on our rubric and on the questions, that's one of them and what it asks for, and this is the work you would show, right, to get that, okay? So my vertex, how do I find the vertex? What am I going to look for first? Does anyone remember? So I want to find the x in my vertex by setting it equal to something. X equals -b over 2a. All right. So I'm going to plug in for my x in my vertex here. So b is 0.5, so negative 0.5 over 2 times a, which is 1. Negative 0.5 over 2, right? So negative 0.5 divided by 2. Can I have a decimal on the outside? No. So bring it over here, there. And we get 4. That's a negative 4, right? Yeah, negative 4. Okay, so the x in my vertex, negative 4. Okay, and then how do I get my y in my vertex? Plug in the x. Okay, so I did my division wrong, right? Negative 0.5 divided by 2. Okay, that makes more sense. Sorry about that, guys. Let me erase my work here. Oh, I see what I did wrong. Sorry. My brain. Not working. It's on Friday. First number goes inside the house, right? This is why we got to do things live, so you can help me out. There we go. That's why you always check your work, too. Okay. So there we go. That makes more sense from what I'm looking at. Okay, and then I'm going to plug it in, find my y, right? So equals negative 0.25 squared minus, or plus 0.5 times negative 0.25, and there's a plus or minus 3. Let's see, minus 3. Okay, and now I'm going to solve. And again, I'm going to make sure to check my work after that first mishap, right? Okay, so then I have a positive 0.0625, right? 4 decimal places, 25 times 25, 6.5. Okay, then I'm going to multiply negative 0.25 times 0.5. So 0.25 times 0.5. We get plus. So it's a negative 0.25 minus 3. So those are subtracting left to right, right? So we get 0.0625 minus 0.125. Oh, my answer. What's happened to my answer here? So here we go. 0.125 minus 0.625. Okay, let me check how we're doing on time real quick. Okay, 8 minutes in. We're good. All right, so gotta borrow. That's 10. That's 5. Okay, that's 4. 6, 2. Gotta borrow again. That's 6. Okay, so I get negative 0.0625 minus 3. Keep, change, flip, and we get negative 3.0625. Okay, so my vertex then would be negative 0.25, negative 3.0625. Okay, so you can leave them as a decimal, or you can convert them into fractions. Okay, I believe 0.625, is that 1/16? Yes, it is. Negative 3 and 1/16. Okay, I just like fractions better. They seem to work better for me, but you can keep them as decimals. Okay, so here I found my quadratic equation. I found my vertex. Okay, and then from there, all I'm looking for are my zeros, right? So for those, I can kind of go in and look negative 0, negative 2, and negative 1.5. And then we have our axis of symmetry, our domain, range, maximum, minimum, y-intercept, and anything else that I'm missing, okay? So all the rest of those you should be able to find from the graph. But that is how you're going to use your graph and your zeros to solve first for your quadratic function, and second for your vertex. And from there, you can tell everything because your x in your vertex is your axis of symmetry. Your range, right? You use the y in the vertex. Your zeros are on the graph. Your y-intercept will be on the graph. I'm just trying to think of everything else, okay? So that wraps up this one for today.